Stat 100 students, and welcome to the pre-lecture for Chapter 8. Now, in Chapter 7, we talked about how the regression line estimates the average value of y for each value of x. However, unless we have that perfect correlation of 1 or negative 1, most of the time our actual values of y are going to be different than those predicted or estimated values of y that we get from the regression line. And the difference between those actual and predicted values is called the prediction error, or the residual. To calculate prediction errors, we're just going to use this formula right here. Pretty self-explanatory. Remember, I said the prediction error is just the difference between the actual value and the predicted value. So the formula is just actual value minus the predicted value. And that's how you get the prediction error, which is also known as the residual. These two words can be used interchangeably to mean the same thing. So now let's look at prediction errors with an actual example. Up here on the board, we have a scatter plot and a regression line with exam 1 scores on our x-axis and exam 2 scores on our y-axis. So what we're trying to do here is predict someone's score on exam 2 given what they got on exam 1. Say that we were asked to find the prediction error for person A. Now remember, prediction error is just actual minus predicted. So person A is way up here, and it looks like they scored a 95% on exam 1. Using our regression line, we predicted that this person would score an 85 on exam 2. However, we can see that person A actually did better than we predicted. Person A, it looks like, scored a 95 on exam 2. That's what they actually got. So for our prediction error, we're just going to look at the distance between this point, the actual point, and our predicted point on the regression line. So our actual score for person A, they actually, again, scored a 95, actual, minus what we predicted. Regression line predicted that they would score an 85. So doing this math, we're going to get a prediction error of 10 for person A. Now, notice that 10 is a positive prediction error, and that's because person A lies above the regression line. They actually did better than we predicted them to do. If we were looking at this person, for example, they lie below the regression line. So we predicted that they did better than they actually did. So this person would have a negative prediction error. So now you guys are probably wondering, what can we do with these prediction errors? Well, first, we could look at the average of them. However, if we have a plot like this with a regression line, the average of the prediction errors is always going to be 0. And this is because all of the negative ones will eventually cancel out the positive ones. So no matter what kind of graph you have, the average of your prediction errors or residuals is always going to be 0. So that doesn't really help us that much. But let's look back when we were talking about what we would predict for a person that got a 95% on exam 1. We said we would predict that they would get an 85% on exam 2. Now that's a pretty bold statement. Wouldn't it be nice if we could say, if they get a 95% on exam 1, I predict that they get an 85, give or take a certain number? That would be nice. It would give us a range rather than just a value. And the standard deviation of the prediction errors allows us to do just that. It tells us the spread of these points around the regression line. You guys know standard deviation measures spread. So it allows us to say that if someone got a 95% on exam 1, we predict that they'd get an 85% on exam 2, give or take that value for the standard deviation of the prediction errors. Now, to find the standard deviation of the prediction errors, we have a nice formula right here that you just only need to know your correlation coefficient and your standard deviation of y, instead of going through the process of actually calculating standard deviation of all of those prediction errors like we did way back in the earlier chapters. So you can use this formula to find the standard deviation of the prediction errors, and it's also known as the RMSE, which stands for root mean squared error. So now let's look at a step-by-step example where we're eventually going to use the RMSE. So in this example it says, last semester about 900 Stat 100 students reported their homework average and final exam scores. The results are shown below. So these are the 5-number summary statistics, and let's assume that the scatter plot was roughly football shaped. Now, the first part of this problem is asking us to predict someone's final exam score who had a 93 homework average. Now this is just your classic problem of predicting final exam score from homework average. So we know that they got a 93, this person, on their homework. And we want to convert that to a z-score. Remember, we want standard units so that we can compare both of these different variables. So the formula for z-score is just value minus average over your standard deviation. So for homework average, we see that the average right here is 90, so our value minus the average over our standard deviation, which is 2. So this is for our z-score for homework. So 93 minus 90 is 3 over 2, so that z-score is just 1.5. So now we have our z-score for homework. We want to get our z-score for final exam. So remember, this is just Chapter 7 material. We're just going to multiply this z-score by our correlation coefficient. So we're going to do 1.5 times 0.4 to get our z-score for final exam. So our z-score for the final is just 1.5 times 0.4, which ends up being 0.6. So now we have two z-scores, one for the homework average, one for the final exam. We want to, remember, predict someone's final exam score. So we have the z-score for final exam. We know this formula. We can predict their final exam score. So we're going to start at the average. The average for the final is 85. And then we're going to add the standard deviation, but remember, we have to multiply it by our z-score. So we're going to add 0.6 times 5. And then when we do that, we end up getting 88 as our prediction for someone who had a 93% homework average. So now, part B here is asking us about how far off do you think this estimate is likely to be. So that estimate that we got from part A, 88 on their final exam, how far off do you think that's likely to be? In other words, this is asking us, what's the root mean squared error, or what's the SD of the prediction errors? Well, instead of actually going through and calculating that, we can just use the formula that was shown before, that the root mean squared error was equal to 1 minus r squared, all under the square root, times your standard deviation of the y. So now it's basically just plug and chug. We know that our correlation coefficient is 0.4. So we have 1 minus 0.4 squared. And then SD of y. Well, if we look at our statistics here, we can see that there are two different SDs. So which one's our SD of y? Well, y, remember, is always what we're trying to predict. So in this case, we're trying to predict final exam scores from the homework average. But the ultimate thing that we're trying to predict is this final exam score. So we're going to use that SD. That's how we know to use 5 as our SD for y. So then you can just put this in your calculator, and what you end up getting is 4.58. So now we can successfully say that if somebody got a 93 for their homework average, we can predict that they'll get an 88, give or take 4.58 on their final exam. So now moving on to part C. Part C says, suppose the person who had a 93 homework average actually got an 86 on their final exam. How far off was your prediction? So this last sentence, how far off was your prediction, is your cue that they're asking for your prediction error. And remember from the beginning of this video, prediction error is just actual minus predicted. So they're saying here that this person actually got an 86. So that's our actual. Minus our predicted. Remember, part A, we were predicting what someone who had a 93 homework average would get on their final exam. And we predicted that they would get an 88. So 86 minus 88. So our prediction error is just -2. And here we see our prediction error is negative, and that's because we predicted them to do better than they actually did. We predicted they'd get an 88, but in reality they got an 86. So we have a -2 prediction error. Thank you for watching and have a nice day.